Let's solve a few more quadratic equations by the quadratic formula. And periodically, I'm just going to be talking to you about how many solutions there are for a quadratic equation. So these are all going to look very similar, but we're just going to talk about the nature of the solution. So remember, 0 has got to be on one side. So see this minus x? It's got to come over to the left side, and so it's going to be a positive x. Please, you have to put this in descending order. So you have to have your x squared term first, then your x term, then your constant. So you can easily see your a value, your b value, which is 1, and your c value, which is 2, in order. So you can see this 1, and this 2. It must be in this order. You must have 0 on one side. Then by the quadratic formula, you take the opposite of the b value. In this case, b is 1, so a negative 1, plus or minus. Then you take your b value and you square it, minus 4 times your a value times your b value, all over 2 times a. Now, see what's under the radical here? It's 1 squared minus 4 times 1 times 2. Well, 1 squared is 1, and 4 times 1 times 2 is 8. And 1 minus 8 is a negative 7. So you'd have a negative 1 plus or minus the square root of a negative 7 over 2. I'm just to have you check this. Under your radical, we had 1 squared minus 4 times 1 times 2. So there's that negative 7 under the radical. I do and need to have you take the square root of a negative 1 out from under the radical and call that j times the square root of 7, all divided by 2. So your two answers are negative 1 plus j times the square root of 7 over 2, and a negative 1 minus j times the square root of 7 over 2. It's not necessary to write that as two different answers, plus they're imaginary answers. So one of the things I want to do is I want to show you this one on the graphing calculator because it has imaginary answers. So you have x squared plus x plus 2. I'm going to hit the zoom key and go back to a standard window. So I'm going to number 6. So I'm just going to hit the number 6 on my calculator. So it takes me back to a negative 10, 10, negative 10, 10 window. Look at my window. I'm hitting my window key because I had adjusted it a minute ago. Well, look, this quadratic equation doesn't cross the x-axis. And that's what happens when you have imaginary answers. It doesn't come and cross through this if you don't have real answers. So with a negative number under the radical, you cannot solve graphically. All right, let's do this next one. So I've got to have 0 on one side of the equation. So I've got to subtract 2 from both sides. And now I'm ready to put in a 1 for A, a 6 for B, and a 7 for C. If I were you, I'd hit pause so you can do this on your own. So the opposite of B, plus or minus the square root of B squared minus 4 times A, which is 1, times C, which is 7, all divided by 2 times A, which is 1. And if I get my calculator out, the number under the radical will be 36 minus 28, which I think is 8. So type that and make sure you get an 8. And then all over 2. Don't forget, I wish for you to think of the square root of 8 as the square root of 4 times the square root of 2, which is 2 times the square root of 2. And so finally, when I simplify this one, there is a 2 that divides into here and into there. And that's what you divide into. There's 2 terms upstairs. So 2 goes into here once, into here once, into here 3 times. So your two answers are a negative 3 plus or minus. You could write the 1 times the square root of 2, or you don't need to write this 1 right here, and you can just write the square root of 2. So 2 answers. And if I wanted to know what those numerical values are for physics, I would just type negative 3 plus the square root of 2 to get one of them, and a negative 3 minus the square root of 2 to get the other. So I have two negative answers for this, negative 1.58, negative 4.414. And you know, if I were to graph this, they'd be something like this, where this is the negative 4 and this is the negative 1 point whatever. So again, I hope you're noticing that all of these problems have two answers, but we are going to come across one that just has one answer fairly soon. Go ahead and keep working. A is 1. Again, you could hit pause. We don't really need to be doing this many, but there are some unusual things that come up. The opposite of b is a negative b. B squared minus 4 times a times c, which is a negative 3. Be careful, there's a couple negatives there, all over 2 times a. If I take my graphing calculator and calculate 5 squared minus 4 times 1 times a negative 3, I probably get 37, all divided by 2. And again, there are two answers. You know, I've been saying to you, how many answers are there? How many answers are there? So when there's a number under the radical, there's two answers. Sometimes it's a positive number, so there's two real answers. And there has been a time where there's been a negative answer, I believe. Where was it? Right here. So there's two answers, but they're both imaginary answers. Again, I don't believe this is the next one. This one is probably one that has imaginary answers as well, because I can kind of recognize those sometimes with all these positive numbers. 1, 1, and 1. So x is the opposite of b, opposite of 1, plus or minus the square root of b squared, minus 4 times a times c, all those are 1s, all over 2 times a. And that's a negative 1 plus or minus. Let's see. 1 squared minus 4. I bet that's a negative 3 under the radical. And then I need you to bring the j out in front of that square root symbol, and then call that j times the square root of 3, all over 2. Okay. Let's talk about number 7, but then solve number 8, and then go to a story. So let's see here. So I just want to mention to you that if, and I'm just so surprised I haven't come up with one that has an answer of 0. I might have to make up one here in a minute because I don't see one. Be sure to distribute. We've got 7x squared plus 14x plus the 5. On the right side, we have 3x squared plus the 3x. So we've got to get 0 on one side. So we'll subtract 3x squared from both sides. And in order to get 0 on this right side, we're going to subtract 3x from both sides. And you would have then here 4x squared plus 11x plus 5 equals 0. And now you would go ahead and put a 4 in for A, an 11 in for B, and a 5 in for C. And I'm going to tell you that when you do that, you get a negative 11 plus or minus, and the number under the radical turns out to be a 41 over 8. I'm going to solve the next few problems in another segment, but before we go there, I want to solve a problem that looks like this. Let's see, 4x squared, I'm making it up, so I've got to be careful. Let's use a 9 here. And 2 and 3 is 6. I think a 12x here. Okay. I've just got to check this really quickly and see if this factors into 2x plus 3 times 2x plus 3. I do believe it does. Yeah, so I wanted to create a problem that has just one answer. And if it was a perfect square trinomial that factors into the same thing, then by the zero product rule, I'd set the 2x plus 3 equal to 0, and I'd subtract 3 from both sides, and then I'd divide by 2. All right, so x is equal to a negative 3 halves. And this would give me a negative 3 halves as well. But I didn't realize I could factor this, so let's just kind of forget about this. And let's put in for A a 4. For B, let's put in a 12. And for C, let's put in a 9 into the quadratic formula. I'm going to erase this. I'm going to keep the fact that I believe the answer is negative 3 halves. So the quadratic formula says to take the opposite of b, plus or minus the square root of b squared, minus 4 times a, which is 4, times c, which is 9, all divided by 2 times a, which is 4. So I've got a negative 12 plus or minus. Let's go to our calculator and find out what the discriminant is. Remember, the discriminant is what's under the radical. That's 12 squared minus 4 times 9. Oh my, a 0 divided by 8. So square root of 0 is 0. So if you took a negative 12 and add 0 to it, and then divide by 8, you'd get a negative 12 over 8. And 4 goes into each of those. 4 goes into the numerator 3 times and into the denominator twice. Well, you wouldn't need to take a negative 12 and subtract 0. When there is nothing to add or subtract, you get what's called a double root that is a negative 3.5. Check out the picture of this. When we graph 4x squared plus 12x plus 9. Remember, I'm looking for where it crosses the x-axis, but I think it crosses the x-axis at just a negative 1.5. And so what happens is this parabola just touches right here at a negative 1.5. I'm going to change my window. I'm going to go from, I think I'll go from a negative 3 to 0. My x, I'll go from a negative 3 to 0. And then I don't need to see so much below the x-axis. I'm going to go from a negative 1 to maybe 2. So I can see that bottom of that parabola a little bit more. Touches right there at a negative, here's 1, here's a negative 2, at a negative 1.5. So a double root, it still touches the x-axis, but just at that spot where I have my solution. We'll come back and do a few story problems, and we're going to do this problem right here that involves a fraction, and we'll finish up using the quadratic formula.